Okay, retina is the membrane on which the image is formed. Okay, is that okay? Okay. And on the retina, there may be two types of cells present. What may be the types of cells present in retina?
The rod cells.
Yeah, rod cells and cone cells. Rod cells and cone cells. What is the function of rod cells?
Intensity of
Yeah, rod cells. Rod cells will help you to detect the intensity, and cone cells. Cone cells,
color.
yeah, to detect colors. After that, there is aqueous and vitreous humor. We forgot about that. Vitreous humor. What is vitreous humor? Also a liquid which is filled between lens and the retina. Which is filled between lens and retina. It will give the shape. It will help to keep the shape of the eyeball. Help to keep the shape of eyeball. Hi Akib, we are just revising our chapter. Okay, Akib? We are
Yes,
just
sir.
revising our chapter. Hi, Jonathan, come. Good to have you. How was vacation? Yeah, good. Did you went to India? No. Then we studied about accommodation. Oh, Sierra is online too. Hi, Sierra. Can you hear me? Sierra Akib.
Yes, sir.
Yeah, okay, good. Then accommodation. What was accommodation? What was accommodation? We can see nearby objects and faraway objects very easily without strain. Right? Yeah, we just adjusting the focal length of our lens with the use of ciliary muscles. The ciliary muscles will be working according to the need, according to the need, right? We need to see this object which is close to us. Then ciliary muscle will be contracting, and it enables us to see this object. When we need to see an object which is far away, the ciliary muscles will be relaxing. It will be relaxing, and the focal length will be increasing. Then we will be able to see the object which is far away, right? Okay. Then what is power of accommodation? Power of accommodation, the range of power that we can achieve, right? The range of power that we can achieve, that is power of accommodation. And there is near point and far point. What is near point? Near point is the least distance at which we can see everything clearly. That is near point. What is far point? The farthest distance. The farthest distance, that is the far point. And after that, for normal eye, what is the near point? For a normal eye, for a normal vision, yeah, it's 25 centimeter average. For a normal human being, it is 25 centimeter. Okay. Then we studied the defects of eye. Defects of eye. What was it? Yeah, short-sightedness or myopia. Then long-sightedness or hypermetropia. Then there was presbyopia. Okay. Another thing also, the astigmatism. Okay. Yeah, then first myopia.
When you see the lights, like a line in the lights.
Yeah, lines will be distorted when we see it. That will be astigmatism. Okay, myopia, nearsightedness. What was myopia? We can clearly see the object very near to us, but not far away objects. Yeah, that's myopia, nearsightedness. Nearsightedness means we can see here. We can see the things which is near. That is nearsightedness, right? What may be the reason for this nearsightedness, short-sightedness, or myopia? What may be the reasons? Elongated eyeballs. Elongated eyeballs, right? Elongated eyeballs. That means the light will be converging in front, right? Light will be converging in front of retina. In front of retina, not on retina. If the light is converging on retina, it will be seeing the object very clearly. But the light is converging in front of retina, or the image is forming in front of retina. Cannot see that object. Okay. What is the corrective measure? How we can correct this myopia? Using concave. Using a biconcave lens. right? Concave lens is a diverging lens. Concave lens is a diverging lens. So when we are using a concave lens, what happens? Yeah, it diverges the light rays, and our eye lens is a convex lens. It then again converges, so the image will be formed on the retina. We have to select the lens according to the power. That's another thing. But the lens we are using is what? Concave lens. The lens we are using is concave lens. That's it. Then there is hypermetropia.
We can see lot.
Yeah, it has another name. Long-sightedness. What was it? We can see very far away objects clearly, but not very close objects. That's hypermetropia or long-sightedness. Yeah. What may be the reasons? Where is the light forming the image? Where is the light converging? Behind the retina. Right? Light is converging behind the retina. Light is not converging at the retina. Image is not forming at the retina. Image is forming behind the retina. What may be the reasons? Behind the retina means eyeball is contracting, shorter length. Eyeballs is in shorter length. The length of the eyeball becomes lesser. That's why the image is formed behind the retina. Or focal length of the lens increases. Somehow focal length of the lens is increasing, then the lens will form the image behind the retina. Got it? So that is hypermetropia. How we can correct hypermetropia? Yeah, using a convex lens. Using a convex lens. What is the nature of convex lens? Yeah, converging lens. It is a converging lens. It will converge the light ray. And our eye lens is again convex lens. It again converges. So the image will be formed at the retina. We have to choose the power accordingly. After that, there is presbyopia. What was presbyopia? Presbyopia?
Long-sightedness and shunt.
Yeah, gradual decrease in the flexibility of the ciliary muscles and lens. Right? Due to aging. It comes due to aging. Not everyone will get that, but some of us will be getting presbyopia. Okay? Oh, a presbyopic person will have both the conditions of nearsightedness and farsightedness. Right? Okay. How we can correct that?
And
With the what type of lens?
concave on the
Bifocal lens. Bifocal lens is the term for that. Bifocal lens. Bi means two. Bifocal lens, a lens having two focal length. How will be that? Yeah, there will be a convex nature to that lens, also a concave nature incorporated with it. Right? It will be like this. It will be like this. If this is the lens, if this is the lens or glass we are using, you may have seen this type of glass with the old age people. If this is the lens and there will be a part like this. Have you seen that? There will be a part like this. This is bifocal lens. Bifocal lens. The upper part will correct far-sightedness and lower part will correct short-sightedness. Okay? Okay. Then we studied prism. Do you remember that prism? What was a prism?
Triangle.
Yeah, prism has two triangular bases and two triangular bases. Yeah, two triangular bases and three rectangular lateral surfaces. Two triangular bases and how many? Three rectangular lateral surfaces. Three rectangular lateral surfaces. If we are looking at a triangle on its base side, it will be looking like it. If we are looking at the prism from the base side, it will be looking like a triangle. It will be looking like a triangle. That is the prism. And there is a term associated with the prism. Which was the term associated with the prism? The term associated with the prism is angle of the prism. The term associated with the prism is angle of the prism. Angle of the prism. Can you see the figure there? Angle of the prism. This is the angle of the prism. What will be the angle of the prism? What is the angle of the prism?
Between two lines.
Yeah, angle of the prism is the angle between two lateral surfaces. Angle between two lateral surfaces. That is the angle of the prism. You get it? Did you get it? Yeah, that's angle of the prism. After that, we studied dispersion. We studied the dispersion. Yeah, there is dispersion, but there is something called refraction through the prism. Right? There is something called a refraction through the prism. What was refraction through the prism? Light gets refracted when it is going through the prism. Light gets refracted when it is going through the prism. How was that refraction? എയ്റ്റിലാണോ ക്ലാസ് എയ്റ്റിലായിരുന്നോ എയ്റ്റിലുണ്ടോ സോറി എയ്റ്റില്ല 7 ഉണ്ടോ Okay, can we continue? What are we discussing? The refraction of light through a prism. Can you see the figure? Refraction of light through a prism. Can you see it?
Yes.
I am drawing a triangular base of prism. This is the triangular base of the prism. When a light ray, I am just selecting only one light ray. You have to understand that. I am just selecting only one light ray. Yeah. This is the light ray. This is the light ray. Just one light ray. Only one light. Okay. What happens to this light? This light ray is called incident ray. Can be called incident ray. This is the ray that is coming, that is going to strike on the surface. That's why we are calling it incident ray. Incident ray. What happens to this light ray? When it is getting incident on the surface obliquely, there is an angle. That's why we are calling it obliquely. There is an angle. Yeah, there is an angle. So what happens? We have to draw a normal curve. How we can draw a normal curve? Normal will be always perpendicular to the surface. Normal is always perpendicular to the surface. Okay. So what does the surface look like? Surface is also inclined. So normal will be perpendicular to that surface. I am going to draw that normal. This is the normal. Can you see that? This is the normal. Normal makes 90-degree angle with the surface. Normal makes 90-degree angle with the surface. So this is normal N1. I am calling it N1. Okay. This is normal and normal is making 90-degree angle with the surface. There will be 90-degree angle like this. Right? Okay. That's the normal. Then what happens to the light ray? Refraction will happen and light ray will bend towards what? Towards normal or away from normal? Towards normal. Why is that? Because yeah, it is no. It is rarer to denser. Here you have air. This is prism which is made of glass. So the light is coming from air to glass. That is rarer to denser. Okay. So the light ray will be bending towards the normal. Light ray will be bending towards the normal. This is the actual path of light ray. I will draw the actual path of light ray. This is the supposed path of light ray, right?
Yeah.
The path, so it is supposed to be going on. But the light ray will not follow that path. Light ray will bend. And light ray will bend towards the normal. It is bending towards the normal like this. Okay? It is bending towards the normal like this. Okay? This light ray can be called a refracted ray. Can be called a refracted ray. Right? Because the ray that gets refracted. It is the ray that is getting refracted. So you can call it refracted ray. Right? There will be angle of incidence here. What is the angle of incidence? The angle between incident ray and normal. That is angle of incidence. Then there will be angle of refraction also. What is angle of refraction? The angle between normal and the refracted ray. This will be angle of refraction. At this point, what happens? It will get refracted again. It will get refracted again. At this point, the light ray will get refracted again. Good? Okay. So you need a normal there also. You need a normal. I can draw that normal perpendicular to the surface like this. Perpendicular to the surface. This is the normal perpendicular to the surface. Right? You can call it normal 2. You can call it normal 2. What happens to the light ray when it is trying to get out of prism? Again refracted. And prism is made of glass and there is air outside. So the light ray will be coming from denser medium to a rarer medium. And light ray will be bending away from the normal. It will be bending away from the normal. So the light ray will be bending like this. Right? You can call this light ray emergent ray. You can call this light ray emergent ray. Emergent ray. So there will be an angle of emergence. What will be angle of emergence? The angle between emergent ray and normal. The angle between emergent ray and normal. Okay. Yeah. We have studied the lateral shift in the previous chapter. Lateral shift. Though we understood that the incident ray gets shifted through a displacement when it is going through a glass slab. This is not a glass slab. It is a glass prism. When light ray is going through a glass prism, something else happens. What is that? Yeah, there is an angle between incident ray and the emergent ray. They are not parallel. Incident ray and emergent ray are not parallel. There is an angle between them. Did you get it? There is an angle between them. What will be that angle? How you can mark that angle in this figure? You can extend the emergent ray like this. If you are extending the emergent ray, you will get an angle that is between incident ray and emergent ray. So this angle here. That angle is called what? D, angle of deviation. That angle is called angle of deviation. So there will be an angle called angle of deviation. An angle of deviation is what? It is the angle between incident ray and emergent ray. Did you get it? So that's angle of deviation. Okay. Then we studied what was spectrum of white light. What was spectrum of white light? Spectrum of white light. Different bands comes together to make this white light. Or in white light, there are 7 component colors. Right? 7 component colors are there. Or every colors in the universe is in white light. Some combinations or other will give you every colors. Okay? Some combinations or the other combinations will give you every colors in the universe. That's why we can see countless or infinitely many colors in this universe. What is the color of this wall? What is the color of the wall? It's almost creamy. You can call it creamy. It's a creamy color. can you observe a creamy color in Vizio in rainbow? No, it is not included in seven component colors of the white light. It is not included in the 7 component colors, but some combinations of these colors will give you this color. That's why we can see this color with this white light. Right? That's it. Right? That is spectrum. What is spectrum? Spectrum is the band of colors. Right? Band of colors. What are those band of colors? Band of colored components. Color components. Band of color components of white light. It is called a spectrum of white light. Okay? Spectrum of light. Then there is 7 fundamental colors, component colors, which are there. Yeah, Vizio. You can start from violet and end at red, or you can start from red and end at violet. That is Vizio. Okay. Okay. Did you study that? Vizio. Violet, indigo, blue, green, yellow, orange, and red. That's Vizio. If we study the Vizio, and the next topic we are going to study, or we did study, what was that? Dispersion. There is a term, there is a phenomena exhibited by light, which is called dispersion. Phenomena exhibited by light, which is called dispersion. What was dispersion? Dispersion. Dispersion is the splitting of the colors. Dispersion is the splitting of white light into its component colors. Splitting of the white light into its component colors. That is dispersion. Splitting of white light into its component colors. It is called dispersion. Okay. Let's see dispersion in the case of a glass prism. In the case of a glass prism, let's see dispersion. If this is a glass prism, I am drawing the triangular base of the glass prism. You can see that, right? And this is the white light that is striking on the surface of the prism. White light that is striking on the surface, right? And this is the path of the light. This is the path of the light. This is the path of the light. Got it? That's the path of the light. And light will get refracted. Light will get refracted. Not only that, it will get dispersed also. There is dispersion happening also. What is dispersion? White beam of light is splitting into its component colors. White light is splitting into its component colors. How will be that? First, there is a red color. First, there is a red color. The light is splitting, and you will get a red color here. Right? Then there is orange. You are getting orange here. Then
Yellow.
there is yellow. You are getting yellow here.
Green.
Yeah. Then green. There is green. Then
Indigo.
yeah,
Blue.
blue.
And
Yeah, it's indigo. Then there is blue. After that, indigo. Then
and
yeah, there is violet. I cannot see violet, so I will use a substitute here. Okay, blue. Yeah, it's not indigo. Yeah, blue. This is what? Vizio, violet, indigo. Yeah, blue is also here, right? Violet, indigo, blue, green, yellow. What is this? Orange. This is red. Right? This is Vizio. 7 component colors of white light. Vizio. So what happens here? The white light is splitting into 7 component colors. White light is splitting into component colors. Can you see that? Can you see that in the board? Yeah. And which light or which color has the least deviation, which has the most deviation? Which light has the least deviation?
Red.
Yeah, red is deviated least. There will be least angle of deviation here. So red is deviated least. And violet is deviated most. Violet is deviated most and red is deviated least. Can you see that? Yeah. Why the dispersion happens? What will be the reason for dispersion? Why the dispersion happens? Because each color in white light will have a different angle of refraction. Why is that? Why is that? Speed of different colors is different in the prism. Right? The speed of red and the speed of orange inside the prism will be different. Right? Speed of orange and speed of yellow will be different in the prism. Right? Speed of each colors will be different. Okay? So the angle of them will be also different. That's why dispersion happens. That's why dispersion happens. They are coming out of the prism at different times actually. Right? But when we are seeing that, we will see different colors. We will be seeing different colors. And after that, we studied the recombination of the spectrum. Recombination of the spectrum. Do you remember that? Recombination of the spectrum. I think that is the last topic we discussed in the previous class. Recombination of the spectrum. What was that? Recombination of the spectrum. This is the first prism. Just the first prism. And the light is entering the prism like this. What happens to this light, right? This beam of light will get dispersed. There will be dispersion happening if this is a white light. Yeah. If this is a white light, dispersion will be happening. If we are just selecting only one ray of light, then you can draw the refraction pattern. Okay. If you are selecting a white light, there will be dispersion happening. Okay. And due to dispersion, the seven component colors will be splitting. Okay. And what happens to the red? Red will be on the top. Red will be on the top. And what about the violet? Violet will be on the bottom. Violet will be on the bottom. Red has the least deviation, while violet has the most deviation. Okay. This is my prism one. What happens at this prism? What happens at this prism? Dispersion is happening at this prism. Dispersion is happening at this prism. Okay. Now we are taking another prism. We are taking another prism and we are keeping the second prism upside down. We are keeping the second prism upside down. If we are taking the second prism upside down, what happens? What happens there? Yeah. The thing that will be happening here will be, there will be a refraction like this for every colors. There is every colors in between. There is a, that's not only red and violet. There will be every colors in between red and violet. Okay. So violet will be deviating like this. Inside the second prism, what happens? Inside the second prism. Yeah. Inside the second prism, a recombination happens. What happens? A recombination happens. Inside the second prism, there is a recombination happening. The recombination. The light rays are recombining. The colors are recombining. The colors are recombining. So the light ray which is coming out will be in white. It will be white. Because there happened a something called a recombination. Okay. So here in the first prism, dispersion happens. In the second prism, what happens? In the second prism, recombination is happening. In the second prism, recombination is happening. Got it? Okay. This is the recombination. Okay. Did we study rainbow? Did we study rainbow? We didn't study rainbow, just this only. Okay, then we can discuss our new topic here. We can start fresh, right? Okay. You will understand that it's very simple. This whole chapter is very simple. There is no calculations, no equations, no numericals, only theory. This chapter is very simple. Okay. Thank God. Okay, we can start. We can start with a fresh topic. That is rainbow. Rainbow. What is the meaning of this rainbow? I think we have discussed this a little bit in the previous class. Do you remember that about the rainbow? No, we did it. You may be not present in the last class. Were you present in the last class? Yeah, okay. That's all. Yeah, rainbow. Every one of you are from Kerala, you are from Tamil Nadu, right? In Malayalam, my language, Kerala. What is rainbow called? Madavillu. Or rainbow. Rainbow. Bow means will. Or is like this. What is this? Yeah, it is bow. It is bow. Okay, that is rainbow. Rainbow, Madavillu. Rainbow. You have seen that, right? Yeah, you have seen that. Rainbow.
What is one means rain?
Now, what is rainbow in Tamil?
Vana
Huh?
Vana will be
Maybe.
Okay.
This is it. This is it. Rainbow. This is not exactly a bow.
That's
Yeah.
straight road.
Yeah, that's it, right. Yeah, you can see a bow here, part of rainbow. It's a part of rainbow. Part of rainbow. It will be extending here like this. It will be extending here like this. Where the rainbow is formed? Of the sky, right? No. Which part of sky? After a rainbow will be formed on the opposite side of the sun. It will be formed on the opposite side of the sun. Right? This is rainbow. And in Malayalam, it has another name also. It has another name also. So, any of you know another name for rainbow in Malayalam? It's called Indradhanus. Indradhanus. It's a purified form of
I
Malayalam.
heard it in
Yeah.
this poem, Malayalam poem.
Ah, yeah. Let me see. Indradhanus. What is the name or meaning of this Indradhanus or Indrachamam? Another name is Indrachamam.
Sanskrit.
Maybe related to Sanskrit. Malayalam has a very tight relation with Sanskrit. Yeah, and Tamil also. Malayalam is actually formed from Tamil and Sanskrit. Tamil and Sanskrit. That's why Malayalam is a little richer. That language is a little richer. Tamil has a flow into it. Tamil has a very nice flow into it. Yeah, I really like that language. It is very simple to hear. That's why Tamil has many rap songs. That's why the language Tamil has very a tremendous collection of a fantastic collection of rap songs. The Tamil language will be mixing with the English very easily. It can be mixed with English easily. Why is that? English has a flow into it, and Tamil has that same flow, so it can be mixed. That's why the Tamil rap are so famous around that part of India. And also nowadays Malayalam raps also are coming, but they are using very colloquial language, very Malabari language. Malabar is the north part of Kerala, and we have that kind of flow also. That slang, Malabari slang has that kind of flow also. So they are mixing that Malabari slang with English. There is your rap. Have you heard about Dabzi?
Yeah.
Yeah, Dabzi is very famous. Maybe in Tamil also. You may have heard some raps about the raps of Dabzi or MHR.
Now everyone is here.
Yeah, Malayalam and Tamil has raps now. Until now, Malayalam didn't have any rap because Malayalam is looking like this. Yeah, it is looking like this. It is so rigid. It's a rigid language. What is the meaning? Indra. Indra is the god of rain, god of gods. In Puranas, Indra is the god of gods, the king of gods. Indra, just like Thor. You know Thor, right? Yeah, god of thunder. Just like that. In Puranas, Indra is god of thunder, god of rain. Yeah. So Indra Chava. Chava means bow. Chava means bow. That means bow. Bow. So Indra Chava means the bow of Indra. It is the bow of Indra. Did you get it? No Shabam. Shabam is curse. Shabam is curse. Shabam is curse. This is Chabam. Chabam means arc. Chabam means just an arc. Yeah? Or Thanus means the bow. Bow. Right? So people may have some beliefs about Puranas and they thought, yeah, there is a bow in the sky. That must be the bow of Indra. That's why they call it Indra Dhanus, Indra Chava. Okay, so that's the rainbow. That is the rainbow, and how the rainbow is formed. Rainbow is formed due to the refraction and the dispersion of light through raindrops. Only if there is raindrop, then the only will be this rainbow form. Without the raindrops in air, there will not be any rainbow. That's why the rainbow is formed on the opposite side of the sun. Okay, yeah. Let's see how the rainbow is formed. Okay, this is a raindrop. It's a raindrop. Light is entering this raindrop like this. Light is entering the raindrop like this. Okay, there will be dispersion happening because when white light is entering into a transparent medium, white light has 7 component colors. White light has 7 component colors. These 7 colors will be splitting. Inside that medium, these 7 colors will be splitting. Okay, I'll just draw red and violet. Is that enough? Red and violet. Okay. So red is splitting. Violet also is splitting. Red is splitting. Violet also is splitting. Okay. When red and violet splitting, there will be every colors in between them. There will be every colors in between them. You have to imagine that. I'm not drawing that. Okay. Then what happens here? What happens here at the boundary of this raindrop? It gets reflected. It gets reflected. It is internally reflected. The reason for that reflection we will study that later. We will study that later when we are at 12th grade. We will study about that. That is called a total internal reflection. Total internal reflection. We have studied that about that a little bit. We may have discussed that a little bit in the previous chapter. Total internal reflection. It will be reflected back. Right? It will be reflected back to the same medium. That's what happens though. It will be reflected back to the same medium. So it is internally reflected like this. It is internally reflected like this. This is reflection now. This is not refraction. It is internally reflected like this. Internally reflected like this. Okay? What happens after this? It is internally reflected like this. And what happens now? What happens now is at this point, refraction happens again. Refraction happens again. refraction is happening again. Refraction is happening again. At this point also, refraction happens. Okay, so the color is the 7 colors are there. White light has split into 7 component colors. Not only that, there is also internal reflection. There is also internal reflection. For an observer on the ground, this is the ground. For an observer on the ground, there will be an angle with an angle to these colors. Different angle to different colors. Different angle to different colors. Right? Violet will have an angle, blue will have another angle, red will have another angle. That's why we can see rainbow. The distribution of these colors. Okay, so how the rainbow is formed? When white light is entering raindrop, first a refraction happens. First a refraction happens. Right? Then dispersion happens. Yeah. There is a refraction and then there is dispersion. Splitting up of these colors. The colors are split. And the colors get internally reflected. Internally. The colors get internally reflected. And finally, when they are coming out of the raindrop, it again refracted. Right? So finally, the 7 component colors are coming out. Each colors will have a different angle. That's why we can see them separately.
So, if it's internally reflected, then it should come in this way.
Yeah, it is internally reflected up to this point. But what happens at this point? The light is coming from one medium to another. If it is coming from one medium to another, again refraction happens. Yeah. Right? At this point, again refraction happens. Got it? Each colors will be refracting at different angles. Red will have a different angle than orange. Orange will have a different angle than yellow. Each colors will be refracting at different angles. So they will be coming out at different angles. One more point also. This is the case of only one rainbow. There will be many, countless many. That's not countless, but to say it figuratively, countless many raindrops. So through every raindrops, the same happens. We will see violet at the same angle. We will see red at another angle. That's why we are seeing rainbow. But what is the actual shape of rainbow? Rainbow is actual shape of rainbow is circular. We are just seeing the part of the rainbow. If you are seeing a rainbow from the plane, that will be circular.
Plane?
Yeah. From plane, the circular rainbow can be seen. Let's see if they have image for that. Yeah, this is it. This is the actual shape of rainbow. Okay, but we are just seeing a part of it.
Why we see when we are
Because of the horizon. We are just standing here. Can you see that? I'm just standing here and I'm looking at that. So the angles will be like that, right? The angles will be like that. And if I am seeing that from above, like this, then there is no horizon. There is no limit to my vision. So I will be seeing the rainbow in circular form, its original form, right? There is more practical here. Yeah. Like this. Right? Okay. So that's it. Did you understand that? Can we write the note about rainbow? Okay. What about Akib, Aaron, Neil, Sierra? You guys did understand that?
Yes, sir.
Yeah, formation of rainbow. Can we write the notes for this?
Yes,
Are
sir.
you up to that?
Yes, sir.
Okay.
Yes, sir.
Okay, thank you. Then you can write. You can write rainbow. That's all. Heading. Rainbow. Rainbow. We don't need this textbook. Yeah. The picture will be same. This is the same picture in the textbook from the textbook. Okay. Okay, you can write rainbow. That's our heading. Rainbow. Rainbow. You can write what is rainbow. No. What is rainbow? We are going to write what is rainbow. A natural spectrum. A natural spectrum. A natural spectrum. Spectrum. A natural spectrum produced by the dispersion of light. Produced by the dispersion of light. Dispersion of light. Produced by the dispersion of light. Dispersion of light. Dispersion of sunlight. If you have space, just write sunlight. Dispersion of sunlight. Dispersion of sunlight by raindrops in the atmosphere. 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 Okay. The next point. Rainbow is formed. Rainbow is formed in the opposite direction of the sun. Rainbow is formed in the opposite direction of the sun. Rainbow is formed in the opposite direction of the sun. Rainbow is formed in the opposite direction of the sun. Okay. Then the subheading. Formation of rainbow. Subheading. Formation of rainbow. Formation of rainbow. Formation of rainbow. Yeah, formation of rainbow. You can draw this figure. This is sunlight. Sunlight. This is red, and this is violet. Formation of rainbow. Formation of rainbow. If you have colors, you can draw it with colors. Okay. Yeah. If you don't have red or violet, you will not be having violet. I'm sure of it. Yeah, you can use different colors of pen or pen and pencil. Everything is okay. If you have no colors, you can just draw that without colors. That will also be okay. Okay. If you don't have any colors, just draw at that and mark red and violet. That will be enough. Mark red and violet. That will be enough. This is red and violet. It will be enough. Okay. It will be enough. Tell me when you finish it. Naveen is absent, right? Yeah. Into,
Last week.
he went last week. When he will be back
Maybe next week.
next week. Did you go to any other places other than India for any trip, something like that? No. Why you didn't go to India? Whole family was here. No one, no one went. Maybe because the job your father had.
Like bicycle.
Yeah.
Can sit.
Yeah. Your family have 6 people. Price was very high. When coming here was highly. High price. Okay, okay, okay. Were you in a summer class here? There was summer class here for mathematics. Yeah, for mathematics there was summer class. Why you joined Excel? NIS?
I heard about Excel.
Okay,
My friend is here. Yeah, but I want.
all the business. Yeah. Jonathan, did you draw that? Yeah. Actually, the tree is here. It is here actually. Internally reflected to show it is internally reflected. That's why I put a 3 there. The light rays are internally reflected. Usually, Jonathan's pictures was usually Jonathan's pictures looking good. You draw, right? I can sense that from your handwriting and your point. Do you have anything that you have drawn? No, so you use paint, oil paint, watercolor, used but no, you didn't develop that. You like to draw, but you didn't develop that skill. You try that. One is just refraction. Just refraction. Second, two is dispersion. 3 is internal reflection. 4 is refraction again. Okay. Finished. Karthik, Siddharth, did you finish it? You had a haircut. From India, I think.
Yes.
Yeah, I can see that. Okay. Your names? Nidal,
After.
Aftab. Okay. Nidal. Nidal is an unusual name.
Yeah.
I have heard Nadal, Rafael Nadal, but this is the first time I am hearing Nidal. Have you heard before any Nidal other than you?
Yeah. One.
Huh?
Yeah.
One is here.
What?
Oh,
Yeah.
okay, okay.
It's the right.
Yeah, it's a red line. Okay, you can write formation of rainbow. After this note, we can take a break. Okay, formation of rainbow is the heading. I hope you have written that heading there. And after the heading, there is a figure. Below the figure, you can write the note. Below the figure, you can write the note. I am giving you the note as points. You can write the note as points. The first point is Water droplets act as small prisms. Water droplets acts as small prisms. Water droplets acts as small prisms. That's the first point. First point. Water droplets acts as small prisms. Did you get it?
Yes.
Okay, the second one. When light enters the water droplet, when light enters the water droplet, when light enters the water droplet, it gets refracted. It gets refracted. It gets refracted and dispersed. It gets refracted or stop there. It gets refracted and dispersion happens. It gets refracted and dispersion happens. Dispersion happens. Then it gets, next point. Then it gets internally reflected. Then it gets internally reflected. Then it gets internally reflected. And finally refracted again. And finally refracted again. And finally refracted again. Then it gets internally reflected and finally refracted again. Okay? The last point. When it comes out, when it comes out of the raindrop, 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 as a result of these processes, when it comes out of the raindrop, comma, as a result of these processes, as a result of these processes, we can observe the rainfall. We can observe the rainfall. We can observe the rainbow. We are seeing each colors at different angles. That's why we are seeing it as a rainbow. Did you understand? Got it? That note? Everyone here, online, Akib, Aaron, Neil, Sierra. Did you get the note?
Yes, sir. Yes, sir.
Thank you, Akib. Thank you, Neil. What about the others? Aaron, Sierra. I'm not hearing you, Sierra. Okay. I got the message from Aaron. Okay, guys. Then we can take a small break. It is 10:37. Okay. We will continue our session at 10:50. Okay. Be back here at 10:50. We can continue our session. Okay.